Food processing facility sanitation is an integral part of good manufacturing practices. Effective sanitation aids in ensuring the wholesomeness, safety, and quality of shell eggs. The negative impacts on food safety and egg quality are a result of microbial growth. Research has shown that ineffective cleaning and sanitation practices or programs can lead to reduced quality duration or potential product contamination. Residual microorganisms can lead to egg spoilage or foodborne illness. Most of this training series will focus on the United States Department of Agriculture Agricultural Marketing Service pre-operational sanitation inspection expectations. However, remember that the Food and Drug Administration has oversight of consumer shell eggs in the United States as stated in 21 CFR 117. Additionally, customers, accrediting organizations, such as Safe Quality Food, British Retail Consortium Global Standard, and others, as well as state and local regulatory agencies, may have additional facility sanitation expectations that can impact your facility. AMS sanitation requirements are meant to protect the integrity of the USDA grade mark by requiring additional sanitation expectations at facilities that utilize AMS voluntary grading services. To meet these goals, AMS inspectors will assess for voluntary grading program requirements during the pre-operational sanitation inspection and throughout processing operations by utilizing organoleptic inspection assessments. While AMS may review microbial test results as part of certain export programs, AMS does not conduct nor require swabbing or biological testing during routine sanitation assessments. So what is organoleptic inspection? Organoleptic inspection assessments include sight, smell, and touch. However, microbial growth will not always be seen, smelled, or felt. Critical areas are defined as equipment with potential surface contact with eggs or come in contact with wash water or air blown to dry the eggs. Non-critical areas are defined as areas that are not likely to imminently affect product quality. Non-critical does not mean it is not important. Non-critical unsatisfactory conditions should be addressed after the processing line has been started, unless unable to safely do so during processing. In this module, the critical and non-critical areas of auxiliary systems present on the processing line will be identified and discussed. For the purposes of this module, auxiliary systems are components or equipment that may or may not be directly attached to the processing line, but are common accessories used in the egg production process. Unsatisfactory critical findings on auxiliary components must be corrected before the component is used, but may not prevent operation of the processing line. Facilities that receive eggs from off-site sources may use equipment to transfer eggs from flats onto the processing line. These loaders may vary in complexity from standalone, hand-loaded units positioned next to the line to more integrated systems with mostly automated egg handling. Regardless of system complexity, loaders use vacuum suction cups to move eggs from flats to the processing line. Vacuum hoses that are connected directly to the suction head assembly are considered critical since air blows out of the line onto the eggs as the vacuum is released. Additionally, any conveyors that the eggs come in contact with are critical components. All egg contact vacuum suction cups, the associated suction head assembly, vacuum hoses, and detection fingers on the flat return are critical. Non-critical loader components may include flat conveyors, flat support mechanisms if present, mechanical gears and drives, structural framework, feet and legs, motors, housing, and electrical wiring, robotic loaders, and pallet conveyors. Suction cups associated with the loader should be presented in a manner that allows for full inspection each day. If suction cups are mounted on the loader in a manner and height that allows for complete viewing of the internal parts from underneath, assessment may be conducted without removing the suction cups. Alternatively, the suction cups that cannot be assessed while mounted should have facility management either mount the suction heads during or after assessment. An improper method of suction cup assessment is to only assess the outside and conical lower lip portion of the cup, usually by bending or flexing the cup while mounted on the loader. Additionally, failure to use a flashlight prevents seeing the bellows further in the cup. A complete suction cup sanitation assessment will include viewing the outside and, with the use of a flashlight, the full internal view of the cup, conical lower lip, bellows, and to the point where it attaches to the suction head. This photo makes it difficult to determine if the cups can be assessed. Therefore, the heads should be removed by facility management if suction cup assessment cannot be completed as mounted. It appears that this set of cups can be assessed while mounted to the machine. While we do not see the internal components of the suction cups in this view, the residual foreign material on the conical lips is an unsatisfactory critical finding and must be corrected before the loader is used. The cups in these two different photos appear to be clean. This is a satisfactory finding on the critical suction cups. Obviously, there are differences in appearance, but discoloration alone does not constitute unsatisfactory findings. The lack of a flashlight prevents the complete internal view of these cups. The conical lower lip of these suction cups has remaining egg residue. This would be an unsatisfactory critical finding. The use of a flashlight shows unsatisfactory conditions within the suction cups as eggshell and egg yolk debris remain in the bellows and where the cups attach to the head. Assessment of this cup finds there is foreign debris remaining in the bellows. This is an unsatisfactory critical finding. A proper assessment with a flashlight of the outside and internal components of these suction cups shows they are satisfactorily clean. For interior vacuum hose assessment, AMS pre-operational inspections are limited to the hoses directly connected to the suction head assembly. These hoses have potential to deposit residues onto the eggs through the head assembly and suction cups. Vacuum hose assessment will be dependent on the material and type of hose. Clear hoses allow for easier visual assessment. There are different colors and materials of vacuum hoses, but discoloration does not warrant an unsatisfactory finding. All three examples of clear hoses are satisfactorily clean. However, a buildup of grime and foreign matter in the hose, as seen here, is an unsatisfactory critical finding. In this shot, we see vacuum hoses that are connected to a white valve before the suction head assembly. While currently a satisfactory finding, if buildup on the outside of the center valve and the accompanying smaller hose, as well as on the top plate of the right suction head assembly, were to worsen beyond what we see here, it would be cause for an unsatisfactory non-critical finding. The interior of the larger hoses appears to be satisfactory. Hoses that are not transparent will need periodic assessment by removing the hoses and conducting assessment with a flashlight. Some loaders are equipped with brushes that perform various functions that need to be assessed. The brushes we see here are satisfactorily clean. The gears, chains, drives, and structural supports are also satisfactorily clean. The small amount of grease seen on the mechanical drives should not be cause for an unsatisfactory finding. All of these components are considered non-critical. Detectors that assess the presence of flats or eggs left in flats are critical because of the potential contact with eggs. These detectors may look different and may be located at different places depending on loader model. The grader should be familiar with the loader to be assessed to ensure all detectors and brushes, if present, are viewed during pre-operational sanitation inspection. The components of this loader, including the detectors, are satisfactory. After being unloaded, plastic flats are commonly washed on site. Plastic flat washing machines are often located in close proximity to loaders and may be either manually loaded or integrated automatic washing systems. Some washing systems will utilize water and chemical cleaners. Others may require manual washing and spin the flats to remove water through centrifugal force. While there are no critical components on flat washing units, the units are monitored for the accumulation of buildup, chemical residue, and eggshells. Components of flat washers may include conveyors, motors, housing, and electrical components, structural framework, feet and legs, filter compartment and filter, if present, machine drain, the wash water reservoir and heating coils, the main wash compartment, including flat holding systems. Units that spin dry flats should be clean on both external and internal components. The interior of this unit is satisfactorily clean. While the external portions of this unit appear satisfactory, the internal assessment reveals unsatisfactory conditions that should be corrected before the unit is used. Here we see an interior view of a drum-style flat washer. Aside from the small bit of residual egg meat and shell seen on the back wall, this washer appears to have been thoroughly cleaned. This is a satisfactory finding in a non-critical area. The discoloration or staining on the top lid is not cause for an unsatisfactory finding. The rust buildup on the back wall of this flat washer is an unsatisfactory finding that needs to be addressed in a timely manner. Operations that use non-wooden pallets may use automated pallet washers. These washers use drive systems to pass the pallet through a chamber where water and chemical cleaners wash and sanitize the pallets. While there are no critical components on pallet washing units, the units are monitored for the accumulation of buildup, chemical residue, eggshells, and other foreign material. Components of pallet washers may include the main wash compartment, water and air filters if present, drains, conveyors, motors, housing, and electrical wiring, structural framework, feet and legs. Some facilities may be equipped with an external part washing cabinet that is designed to clean components that are easily removed from the machine. These part washers are usually located in the processing room in close proximity to the grading and packing equipment. While there are no critical components on part washing units, the units are monitored for the accumulation of buildup, chemical residue, eggshells, and other foreign material. Components of part washers may include parts holding rack, loading ramps, internal and external walls, spray nozzles, plumbing lines, and control panel. Parts washers should be thoroughly cleaned after use. All interior components should be free of residual shells, egg meat, and excessive soap residues. Excess moisture, as seen on this interior door panel, is acceptable as long as the surface is clean. The parts washers should also be kept in good repair to prevent deterioration. The hose in this photo may no longer be able to function properly, which could reduce the effectiveness of the washer or even allow for small rubber particulates to come loose during the wash cycle. This could lead to a physical contamination hazard if left on the packer components after the wash cycle is completed. A variety of machines exist to separate inedible eggs into shells and liquids. Even though these systems are for processing inedible eggs, they must be thoroughly cleaned after use. If obvious odors are found during organoleptic inspection, disassembly of the unit may be required to find and correct problem areas. Inedible egg separation is usually done by either centrifugal force or by pressing liquid egg through a mesh screen. Once separated, the liquids may be denatured and transported elsewhere for further disposition. Components of inedible egg separation systems may include the hopper or egg separator parts, exterior panels and framework, control panels, electrical wires, pipes, pneumatic tubing, motors and motor housing, catch pans or trays, holding tanks or totes. This is a typical view of the mesh screen as seen during preoperative inspection. Units that can be easily disassembled should be viewed from both the inside and outside during inspection. Components that are not easily disassembled will quickly develop foul odors, which is evidence of improper cleaning. Small bits of residual shells, as seen on the top of this unit, are acceptable. This is a satisfactory finding in a non-critical area. Here we see the auger that pushes inedible eggs through the separation system. All surfaces of this component are thoroughly cleaned. Graders should never reach inside of the system with their hands to evaluate the non-visible components, thereby avoiding any possibility of accident or injury. This is a satisfactory finding in a non-critical area. Inedible egg separation systems are highly likely to cause spillage in the surrounding areas during operation. It is important to maintain a reasonable level of cleanliness throughout the processing shift, which may require a great deal of attention. In this photo of a press during mid-shift operation, buckets are placed beneath the machine to catch runoff. These buckets must be emptied as often as necessary to prevent overflow. The egg and shells on the floor seen here is excessive and must be corrected as often as necessary to maintain sanitary conditions. There are many styles and configurations for auxiliary systems for egg processing. It is important to familiarize yourself with each egg processing system you encounter to ensure the auxiliary systems are effectively evaluated before processing begins each day. Keep in mind, in any system, egg contact areas and associated components are critical.